Hello and welcome to my talk to the text assignment for literacy. I chose a word problem out of a geometry book, and I'm going to go over the issues students may face while reading this problem. So one thing I would want everyone to look at the beginning is the introduction to the problem, where they say the big idea is on similarity. And the hint that they give is you can use trigonometric ratios to find the lengths of sides of right triangles. So as soon as students see the word trig ratios, they should think of the three that we learned in previous classes: sine, cosine, and tangent. And the next word, right triangles, it's pretty common. That is just a triangle that has one right angle. So I would expect my students to know these two things before even starting this problem. And what I did was I covered up the picture in this diagram because I want my students to read the words to get a visual of what is going on and what's being asked. So it starts off with a construction crew wants to hoist a heavy beam so that it is standing up straight. So when I see the word heavy beam, I automatically think to, okay, skyscrapers that were built in New York City, and seeing images of heavy beams being used to make the town's skyscrapers. So a heavy beam is going to be a large beam that is rather large. They tie a rope to the beam, they secure the base, and pull the rope through a pulley to raise one end of the beam from the ground. So that sentence has a lot going on in it, and I think the first thing that confuses me, okay, is where are they going to tie the rope on the beam? Are they going to tie it on this side, the middle, or maybe the end? I wouldn't want my students to get distracted with where to tie the rope, because essentially we're just raising the beam to stand it up straight. And then when they're going to secure the base of the beam, they're talking about, okay, well, if we have the ground of a construction project, one of the ends of the beam is going to be secured in the ground. It's going to stay put. It's not going to move. And they're going to pull the rope through a pulley to raise one end of the beam from the ground. I feel like this may cause confusion because everyone might not know what a pulley is. So I'm going to highlight that word, a pulley. And to give them a visual, I would say, have you ever seen someone dry their laundry in the front yard where shirts, pants, jackets are hung up on a clothesline? And then I would say the line that holds the clothes is attached to a pulley so that people can pull the line to fetch whatever piece of clothing they need. So the next sentence, when a beam makes an angle of 40 degrees with the ground, the top of the beam is 8 feet above the ground. So that again is a lot of information. So let's break that down. When the beam makes an angle of 40 degrees with the ground. So let's say this is my beam. I'm going to move it so that it's attached to the ground. I'm going to make it a little bit shorter. So when it's attached, when it's secured to the ground, the beam can be lifted like so, like this. And what they're saying next is when the beam makes an angle of 40 degrees with the ground, so the angle is formed right there with the ground and the beam. And if we draw a line that will connect the end of the beam with the ground, the color you can actually see. The end of the beam with the ground, they're saying that this distance is 8 feet. So if you notice, we have just drawn a right triangle. And our right angle is going to be formed between the yellow line and the brown. So there's a right triangle. So then it says, the construction site has some telephone wires crossing it. The workers are concerned that the beam may hit the wires. So if we have some wires going across the top of the screen right here, they are worried that, let's make the beam a little bit longer. They are worried that the beam may hit those wires and they're trying to stand it up at the right height. Make it right there. And then the next sentence says, okay, well, when the beam makes an angle of 60 degrees with the ground, the wires are 2 feet above the top of the beam. So with that diagram, we're going to have another picture. So if I were to get this a little bit closer to the beam, draw a line from the top of the beam to the ground, which will make a 90-degree angle. And then they're saying this new angle between the beam and the ground is 60 degrees. So they're saying now there's a 2-foot gap right here between the beam and the wires. So now they're asking, will the beam clear the wires on its way to standing straight up? And they want us to explain it. So we're going to need 2 pieces of information. The first piece we're going to need is, okay, well, what is the length of our beam? If we know the length of our beam, we can find out how much space we'll have before it hits the wires. But then we also need to find out, okay, well, what is the distance from the wires to the ground? Or the height. So let me write that. We need the height of the wires, and we need the length of the beam. So once we find those 2 pieces of information, we can figure out whether or not the beam will be able to clear the wires when it's standing straight up.